Hello, today we're going to talk about subtracting and adding, or adding and subtracting, polynomials. This is our first part into Chapter 9, Lesson 1. The first two examples in this lesson are extremely vocabulary heavy. So we're going to spend some time on going over the vocabulary, looking over some example problems, and then we'll get into the math end on examples 3 and 4. So here's the pages we should be at in our book. Feel free to pause this video to get caught up on the vocabulary, and then again at the end to work on the quick checks. So here we go. Let's get started. So what we're going to learn today, we're going to learn how to classify polynomials, okay? And then we're going to learn how to add and subtract them. The adding one is really easy. The subtracting one, there's a little trick about distributing the subtraction symbol, and then it's basically the same thing. And we'll go on from there. So let's get started. So the vocabulary. The first vocabulary word in this section is monomial. And a monomial is an expression that is a number, a variable, or a product of a number and one or more variables. So what that basically means is anything that's connected by multiplication. So all of that stuff in Chapter 8 was a monomial. There was no addition or subtraction. Okay, so monomial has no addition or subtraction. Okay, so again, none of that. No addition or this is awful. Subtraction. Oh, let's just use a minus symbol. So if you see a plus or minus in it, it is not a monomial. All right. So moving on. The next one. I have to get back to my pointer. All right. So I had to talk to Mr. Ubroth there for a little bit. So anyway, degree of a monomial is the sum of the exponents of its variables. All right. Make sure you understand that is the variables, not the constant doesn't matter, just the exponent on the variables. All right, and we'll talk about that in a second. All right, examples. So these are all monomials. Here's a monomial. Again, no addition, subtraction. We do have a negative sign, but I'm not adding or subtracting anything to it. All right, and this is a first degree monomial. There's one exponent. There you don't really see an exponent. I'm sorry, there's one variable. You don't see the exponent, so that's an exponent of 1. This has a degree of 1. This is also called linear. We'll talk about that on the next slide. 3x squared y. Again, no addition, subtraction, so it's a monomial. And the degree of this monomial is 2, and 1 is 3. So this is the third degree. Okay. Again, no addition, subtraction. There's a single variable with a squared, so this is a second degree. Okay, we call this quadratic. And then this one here, kind of a little crazy. I got 1, 2, 3, 4. I got 5 variables. 1 on the A, plus 2, that's 3, 4, 5, 6 degrees on this one. All right. We're not going to be finding the degrees of monomials very often, mostly just in this section. It's not hugely important for the rest of the chapter, but there are questions that revolve around this, so we have to cover it. All right, and I believe on your final exam there are some simple ones like what's the degree of this monomial. So it's kind of a gimme question. I want to make sure I cover it. All right, so these are all monomials because there's no addition, subtraction, not adding or subtracting anything to these. Okay, and the degrees are the sum of the exponents on just the variables. 1 degree, 3 degree, 2 degree, 6 degree. All right, so the reason I wanted to show you this example 1 quick check is simply for this 18 here. Constants have a degree of 0. So the answer to A is 0. It's a 0 degree. B, give you a second to think about it. It's 4. And the degree of C, again, give you a second. And that's 1. So 0, 4, and 1 are the degrees of each of these monomials. All right, let's get into the good stuff. So a polynomial. Poly means many. All right. And a variable expression consisting of many terms that can't be combined. So their exponents on their variables are different, or it's just different variables altogether. There's going to be addition, subtraction in between these, and we're going to classify polynomials as well. All right. So the degree of the polynomial, this is a little easier, is the largest exponent in the polynomial. All right. So if the largest exponent is x squared, it's a degree 2 or a quadratic. If the largest exponent is 6, there's a 6th degree. I'll go over the naming in a couple slides. But degree of a polynomial is the largest exponent in the polynomial. Standard form means of a polynomial means that the degrees of its monomials terms decrease from left to right. So the biggest exponent, so if it's x to the fourth, that's the largest exponent on the variables. That will be on the left, and then maybe x cubed, x squared, x, and then maybe a constant. They have to be in descending order. All right. Example. Here is a perfect example of a standard form of a polynomial. The largest exponent, 4, is first, and then 2 is smaller than that, 1 is smaller than that, and then the constant is last. This is a standard form of a polynomial. You'll be writing in this order throughout the chapter. Okay? So again, I got to put them in order. This term has the largest degree, second largest, third largest, and the fourth largest. All right. And as a degree of this polynomial is 4. So I'm naming it, this term up here, from the largest. It's a fourth degree polynomial. Okay? Moving on. Binomials are, bi means two, like a bicycle, all right, or binoculars. So any polynomial that's made of just two terms. So, for example, two-term polynomial looks like this. X cubed minus x is a binomial. 2y plus 3, one term, two terms, binomial. It's a two-term polynomial. The degree of this one, by the way, is 3, or cubic, and then the degree of this one is 1, or linear. And then n squared plus 4 is a two-term polynomial, which is called, again, a binomial. N squared and n, this is a quadratic, or second degree binomial. Trinomial. How many terms do you think are in here? Tri, like tricycle, 3. Three-term polynomial. Some examples: x squared minus 3x plus 4. This is where you're going to live for most of this chapter. They are going to be trinomials with a degree of 2, or a quadratic trinomial. Know this, learn it, love it. You're going to be here all chapter. All right. 7y to the fourth plus 3y squared minus 1. Again, these are in standard form. The 4 is first, the 2 is second, the constant is third. This is a fourth degree trinomial. All right. You name a polynomial by its degree, then its number of terms. And there's a chart in Chapter 9, and this is basically the chart. So let's take a look. Here's the polynomial. All right. It is a two-term polynomial, so it is a binomial. We'll get to that there. Its degree is 1. Right? The exponent on this x is 1. There's no other exponents. So the largest degree is 1. It's a first degree. Name using degree. This is linear. So anything with a 1 exponent is linear. That's a vocabulary term. Number of terms, 1, 2. So that's 2. Name using number of terms, it's a binomial. So this is a linear binomial. Linear binomial. Here we go. Here's our trinomial. Its degree is 2. There's a special name for 2 when it's the largest. It's quadratic. How many terms? 1, 2, 3. And there's a special name for 3 terms. That's trinomial. So this is a quadratic trinomial. Again, you'll be living here for all of Chapter 9. Most of Chapter 9. All right. This is a monomial. Its degree, you can see, is 3. There's a special name for a degree of 3. It's cubic. Right? We've talked about that. Number of terms, 1. It's a monomial. This is a cubic monomial. 9x to the fourth plus 11x. Its degree is 4. There is no special name for 4, just fourth degree. So we have our special names for 1, 2, and 3. We do not for 4. Number of terms, 2. That's a binomial, fourth degree binomial. This chart is right in your book, so don't worry about trying to keep up here. Just follow along. 5 degree. It's 0 degree. It's a constant. There's 1 term, so it's a monomial. And we just call these constants, or a constant monomial. All right? Again, look at the chart. It's pretty straightforward. You need to know what linear is. You need to know what quadratic is. You need to know what cubic is. And after cubic, the degree is just 4th degree, 5th degree, 6th degree, 7th degree. And we just went over the last binomial, trinomial. If there's 4 terms, it goes back to a polynomial. There's no special name for 4 terms. It's just polynomial. So binomial, trinomial, or monomial are the special names. After 3 terms, it is just a polynomial. All right, so write its polynomial in standard form, then name each polynomial by its degree and number of terms. So, what we have here, I have to put it in standard form. I'm going to try to write this with the mouse again. We'll see how well this works. 7x is the largest monomial, so I write that first, 7x minus 2. All right, that is standard form. This is a linear linear binomial. All right. This one here, I combine like terms, so 3x to the fifth minus 2x to the fifth is just x to the fifth. I have a constant here term and a linear term here, so my linear term is next, plus 7x minus 2. And there's no special name for 5, so it's a fifth degree trinomial. All right, so that's about as hard as it gets, combining like terms here. Putting them in order, the fifth degree, if there had been a fourth, that would have been next. If there had been a third, that would have been after that. But it went from 5 to 1 to 0, so that's the order I put it in. And then again, I name it by the largest exponent, which was 5, fifth degree. There was 1, 2, 3 terms, trinomial. All right, now, moving on. Add the following polynomials. All you have to do for these, there's no trick, just combine like terms. Okay? In fact, in these addition problems, you really don't even need the parentheses. If you see an addition between the two binomials or trinomials, whatever they are, you just have to combine like terms. So it's a plus 3a is 4a, and 2 plus negative 9, or 2 minus 9, is negative 7. Okay? And that is a linear, that's a linear binomial. All right. Another addition. Again, the addition sign's between the parentheses. So no trick, just combine like terms. X squared plus 7x squared is 8x squared. There's nothing to combine with the x, so that's just minus x. And there's nothing to combine with the 5, so that's minus 5. And we get that again. X squared plus 7x squared is 8x squared. Nothing to combine with the minus x, so that stays minus x. Same thing with the negative 5, minus 5. And if you're keeping track at home, this would be a quadratic, because there's a 2 here, trinomial. All right, last addition problem. 4y squared, again, nothing really to do with the plus when you're adding them. 4y squared minus y squared is 3y squared, right? And then negative 3y plus 8y is positive 5y. And then there's nothing to combine with the 7. Whoops. So I get that. Again, 4y squared minus y squared is 3y squared. 3y, negative 3y plus 8y is 5y. And nothing to combine with the 7, so I just bring it down. And that's what we get. This is a quadratic trinomial. All right. Linear binomial, 1 here. Linear, 2 terms, binomial. Quadratic for the 2 and 3 terms, quadratic trinomial. And then again, quadratic trinomial. All right, moving on. Subtracting polynomials, distribute the negative. So we have to distribute this negative to both terms inside that second set of parentheses. So this is actually minus 2x squared and minus 4. All right, so let's put it on the paper. So again, distribute your negative. You're going to get 8x squared minus 5. Nothing changed over here. And then I distributed the negative, so minus 2x squared minus 4. Now you combine it like terms. 8x squared minus 2x squared is 6x squared. And then negative 5 minus 4 is negative 9. And that is a quadratic binomial. Okay? Next one, again, distributing the negative sign. So 4k squared becomes negative 4k squared, and negative 2k becomes positive 2k when I distribute. This side, nothing changes, but get rid of the parentheses. Okay, so I brought everything down as is in the first set. I changed the signs on the second set. Combine your like terms. Negative 6k squared minus 4k squared is negative 10k squared. Negative 3k